All right. Good morning, good afternoon, good evening. Depends on where are you in this world. Today, we're gonna have two new sellers on the marketplace who will present their solutions. Welcome to the Niagara Marketplace Content Spotlight. I hope you find it useful and in your day-to-day jobs and your projects and in your business. My name is Pavlo Podolsky. I'm Channel Enablement Leader for Global Tridium Business, and today I will be your host. So, agenda. We will start with a short marketplace overview, just a reminder, or if you're new to the marketplace spotlights, it would be, I'm sure, an interesting information to share with. Then we are going to go to product presentation. We'll start with Candela IoT with the Tesla Fleet API driver, and then NSES, Nimbus Stratus Energy Solutions with the Nimbus Fund block. And we will end up our TridiumTalk with the Q&A session, where you will be able to ask anything about the marketplace or the presented products today. So just few words about the challenges that we see on the market. If you're an integrator, a big challenge is where do I find correct solutions for my customers? Where do I buy them? Do I have enough overview? Do I need to spend a lot of time in search, right? Can I expand my business knowing that there are solutions I wasn't aware about before? If I'm a developer, how do I distribute across the world what I've built? How do I sell? How do I find my channels? How do I find those integrators and give them an opportunity to use my solution in their projects? And that's where the marketplace comes in, because that's the place that bridges those gaps, creates those connections between developers and system integrators, and creates an ability to find those solutions and to bring much more to your customers. It's sell more, sell easier for developers, and deliver a better speed and quality for system integrators. Effectively work smarter. What are the benefits of the marketplace? Well, first and foremost, it's an easy access to Niagara solutions and enhancements, right? Wherever you are in the world, of course, in the countries where the marketplace is available, you can find any solutions from all the other countries. You don't need just to look in what's available in the distribution where you're used to buy from. You can find powerful tools um, there, and it gives powerful tools for sellers to present their product, for sellers meaning developers. You can use integrations that we have with Niagara Central to be able to license and connect, attach those solutions to the Niagara license, and Stripe solutions to be able to process the payments and process that whole sales motion. And of course, reach a broader audience for the developers, reach the Niagara community audience. As well, we have special additional benefits for members of Niagara developer program, which is additional discounted commission rate, additional promotional opportunities, and of course, badging that you can see on the marketplace when you browse solutions. You can see premium or cloud developers there. So these are few benefits of a marketplace. And of course, if you have any questions or you want to browse it and then ask questions after this Tridium talk, please make sure that you reach out to me, and I will be happy to help you. So right now we start with the Tesla Fleet API presentation, which will be done by Chuck Han from Candela. And here you have a QR code that will lead you directly to the Tesla Fleet API page on the marketplace. So if you want to, I'm going to keep it for a minute so you can, if you want to scan this QR code and see it on the marketplace directly, please do so. All right, Chuck, I think you can start your presentation.
Okay, thank you, Pablo. For those of you that are QR code challenged, just go to the marketplace. Um, if you just type in Tesla in the search bar, we're the only product that comes up, so you can get it this way. We have two versions, like a lot of drivers. We have a Jace version and a supervisor version. And at any time during this talk, or if you download the products or any products that I'll be presenting in the future, you can contact us at support@gobms.com. So before I start, I just want to give my thanks to everybody that's made this and our product possible in the Tridium family. Danielle, Michael, Nicole, Stephen, Sandra, Trey, my instructor, and Kevin. So I'm going to start out by talking about the name of our product, Tesla, and I've grayed out Fleet API driver, because when you think about Tesla, you usually think about cars, and that's just reinforced by the name of the API that we use, Tesla Fleet. But we aren't using it for cars or car charging or anything like that. What we're using our driver for is to interact with solar installations. That includes power walls, grid and consumption monitoring, et cetera. So it is not about cars. So I just wanted to make that clear. So here's our overview. We'll talk about what version is right for you. Why do you need our driver in the first place? How do you install, set up, and use? And then more exciting for us is when will these apps, an optimizer and digital twin apps that run on top of the driver, be available? Okay, so first of all, what version is appropriate for you? If you have a single building or just a couple buildings and a Jace, then it makes sense for you to install our driver directly on that Jace to interact with power walls and solar panels on your building. However, if you have a network of buildings that have these solar installations, then it makes sense to buy the supervisor version. With the supervisor version, you can install multiple instances of our driver, each driver being associated with a Tesla account, and then connect up to your individual buildings or JACEs themselves. Okay, but why do you need our driver in the first place? Those of you who are familiar with Tesla installations know that you can have an app, like a phone app, and see everything you want to see and actually interact with your solar installation. However, what our driver provides is the ability to see multiple sites in one environment, all in the Niagara environment, that is. And then once you have that, then your Tesla devices and points are treated like any other Niagara devices and points. So it's a, one-stop shop, which is exactly what we're using Niagara for in the first place. And then, of course, you can run something like Niagara Analytics. Kevin gave a talk earlier, a Tridium talk, where he presented a simulation of a solar energy production application monitoring solar and storage. In this case, with our driver, you can substitute the word simulation and put our driver in, and then this will be something that runs live. But most importantly for us, once you have our driver, then you can immediately start to save money by optimizing your Tesla installations, right? That's the key here. And we'll go into this a little bit more. Here's actually data from our prototype optimizer where we leverage something called time of use pricing, and this is available from a utility company. The green bar shows where electricity is cheapest. The orange bar shows where it's most expensive, blue being something intermediary. What our optimizer does is it charges the battery up during the least expensive time of power or electricity, and then discharges it when power is most expensive. When that happens, then you're avoiding grid draw, so you're not drawing power from the grid. It's a very simple algorithm, but once you install our optimizer and enable it on top of the Tesla Fleet API driver that we provide, you'll be saving money immediately. All right, so let's go into some of the details. Very simple. You just drag and drop our driver into the driver folder of your Niagara workbench. Again, you can drop in as many drivers as you have Tesla accounts. There's quick authentication, and then there's a one-step setup, and then you'll be able to read and write sensors as you would for any Niagara device. Right. So here's a view of my workbench. As you can see in the driver folder, I've already got two instances of the driver running at different addresses. So all I'm going to do is from our palette, just drag and drop in an additional driver. I'm going to name it with the appropriate address. And then once that happens, then you can see that there are a couple of endpoints. There's an authorization endpoint that we'll be signing into, but then additionally, there are several other components within the energy folder. You'll notice that one of my endpoints is stale. That's because we haven't authenticated yet. There's this energy site template. It's a template because we don't know what energy sites are available until we actually sign in. So once we set up, we'll be able to see what site or sites are generated. Authentication is pretty straightforward. You just double click on the authorization endpoint. The default view is this PX page. If those of you who have Tesla accounts are familiar with this, I'm just going to sign in. And then I'm sure everybody uses two-factor authentication. And then once you're verified, once you're signed in, we actually show the access and refresh tokens that are necessary to access the Tesla endpoints for your particular site. You don't necessarily have to do anything with this. They're automatically populated, but we're showing them anyway. If I go back to my energy folder, you'll notice that this endpoint is now enabled and it's actually spitting out what energy site or sites are available. When we run setup, and setup is very straightforward, you just right click on the driver itself. The energy site or sites for this particular Tesla account are generated. And if I dive into this, then you'll see the energy endpoints that are available for this particular driver. Notice that two of them are enabled. These are actually streaming live data as we speak at the normal polling rate. Polling rate is something that you set in your Niagara environment. The other endpoints that are available are disabled. They are only enabled when you actually give it some kind of input. Then they're enabled temporarily, and then whatever information you've sent to your Tesla installation, you can verify that it's there, right? So let's dive in and take a look. So here is, for example, the live status endpoint, and you can see that this particular one gives me the loads that are available that are being projected from the Tesla site. So right now I have nothing from either battery or generator power. Everything is right now coming from the grid. The grid is actually matching the load or the consumption, which makes sense because nothing else is active right now. My site has no solar power at this point. So again, the live status and site info endpoints show you the sensors, and they're being polled at a rate of like a minute or so. If I go to an endpoint where I can actually set data, for example, there's this backup endpoint where I can set something called the battery reserve percent. So again, this is a normal point. So all I do is set it. So if I set it for, let's say 75%, it's disabled right now, but immediately it now becomes enabled, and it gives you back a code to verify that, in fact, something has been done. This value has been sent to my Tesla site, and I can verify that by looking at the site info. In this case, this is a sensor, and it says that the battery reserve percent is currently at 50. The reason it says 50 is because it hasn't updated. I can force a poll or an update by sending the action from the proxy extension. The minute I do that, you can see that this has changed. All right, so that's pretty much it. It's very simple. Drag the driver in, authenticate, set it up, and then you're ready to go in terms of reading and writing sensors and set points manually. But as we talked about earlier, the power is with analytics or applications that are written on top of it. All right, so my next slide was when. So first of all, as we said, Niagara Analytics and the Niagara Cloud Suite, which is Niagara Data Service dashboard, these are available now. We provided hooks for streaming the historical data so you can see it within the dashboard itself, right? And in fact, the screen that I showed you before was the NCS NDS dashboard for the battery percentage. This is a view of the prototype optimizer with the loads that are on the building. And again, this data is coming directly from the Tesla driver, where I'm showing that I'm charging up the battery during the off-peak hours, and I'm discharging it during the peak hours. And as you can see, there's no grid draw when I'm doing that. So again, we're saving money immediately when we enable our optimizer. The optimizer will be available later this summer. We'll have some additional digital twin apps, both of these running on top of the Niagara, I'm sorry, on top of our driver. And again, we're looking for pilots to test out our optimizer. And if you're interested, you can contact us. Again, the email address is support@gobms.io. The optimizer will initially be NCS NDS powered application using their API. In order to, what happens is it's just a web app, right? Where you put in your credentials, your NCS NDS credentials, sign in, and then the first page will be a dashboard of all the energy sites that are available from your Niagara environment. If you recall, I had two addresses, and then I added this third one. So they'll show up. They'll show up in a Google map of exactly where they are. If I drill down to one of the sites, again, I have to add this thing called the time of use chart in order to have the optimizer actually work. Here are graphs of the running in real time where, again, I'm charging up the battery during off-peak hours, I'm discharging it during peak hours, and I'm not drawing from the grid. We'll have some indication of the estimated money that you save running our optimizer with the range, either a day, 3 days, or whatever. But this is the main thing that we're really interested and excited about. All right, so finally, give us guidance. What other drivers would you like to see? We've focused on Tesla, but we know there are other storage solar solutions out there. We've written one driver. We can easily write the next one, and then we can easily write an optimization application for a whole slew of them. So any other additional functionality, any installation usage challenges, any user guide questions, please do give us a call. Again, our number is support@gobms.io. Thank you.
Well, thank you, Chuck. It was a very interesting to see your solution. All right, so now we're gonna go to the Nimbus Stratus, and Omar, the floor is yours.
Thank you, Pavlo. Let me just share my screen here. Okay, do you see my screen?
Yes.
Okay, perfect. Okay, well, hello everybody, and thank you for joining us today. I appreciate your time. My name is Omar Nassif. I'm a software engineer with Nimbus Energy Solutions. A little bit about us: we're primarily based in the DC area. We are a certified Tridium developer, and the company works primarily in the building automation space with projects such as system integration, control sequence programming, analytics, dashboards, and any kind of custom software solutions that are required from clients, as well as consulting. So just before getting into the main module that we're presenting today, I wanted to present two other modules that we have coming up. One is Nimbus graphics tools. So this one is composed of two parts. One is a Niagara service, and the purpose of the service is to help to manage the graphics that are on a station. So it would show you a list of all the graphics that you have. And all the PX files and which files are associated with which views. It helps to generate error reports about the graphics. So a lot of times, PX graphics are done pretty quickly, so you end up with broken ORDs here or there or invalid B formats, amongst other common errors. So this service would help you quickly identify that from a central view. And then another thing we're very excited about with this is for control points that are on the station, the service would allow you to see all the control points on your station and identify which graphic each control point is on, and then also which widgets it's bound to. So no more of forgetting to add a point to a graphic or not knowing which graphic a point is on. And then the other part that's in this module is a PX editor sidebar. I'll show a screenshot in a second. But the purpose of the sidebar is to provide some extra tools that we felt were missing from the base PX editor to help streamline graphic creation and reduce clicks and human error. So here's a basic view of what the service would look like. It has two tabs. One is the graphics tab, and which would show all the graphics that are on the station. But for the purpose of just today, I wanted to quickly highlight. So on the points tab, we have a list of all the points on an example station. We have a column that says true or false whether a point is on a graphic. So I can see that all these points here are missing, whereas this point is on a graphic, and then when I click on it, it shows me that it's on this graphic here. And when I double click on it, it'll take me to the graphic and highlight all the widgets that have that that are bound to that point. And then this is the PX editor sidebar that I mentioned. So it has things like, for example, batch binding ORDs. So you can highlight a bunch of ORDs in your navigation tree and highlight a bunch of widgets and automatically bind the ORDs. You could do search and replace on certain widget properties. You can also highlight which points from a folder are missing on the graphic. So if you're working on a specific equipment and you have, let's say, 50 or 60 points, and you're not sure if you've forgotten a point, then you can quickly click this button down here, and it will highlight which points from that folder are missing. So this is for the Nimbus graphics tools. Another tool we have coming up is Nimbus workbench tools, and this is on the workbench side. So this is, you only have to install it on your own workbench, and essentially this is like a program service, but on steroids, where it gives you a lot more granular control over things such as facets, flags. It displays all that information for you. For example, in program service, you can't easily see which flags are on which slots, whereas with this, it'll show you every slot and which flags are there. Also things like display names of slots, so it allows very easy individual and batch control of all of these aspects of points. And this is sort of what it looks like. So in this example here, I pulled up a bunch of Boolean points, and by default, Boolean points have the active and inactive action. And whereas with program service, you would have to batch add a display names slot, and it's not very user friendly. But with this, we pull up all the slots and we show what the display names are, and then you can click individual ones or batch edit them if you'd like. So just quickly highlighting, in the future, we'll talk more details about these two modules. Okay, so the primary focus for today is the Nimbus func blocks or function blocks. So as you'll notice with our other modules, our philosophy really is we like to see how building automation technicians are working. Where are they wasting a lot of clicks? What are the common errors that uh, they would run into, like human error, and where a lot of time essentially is wasted. Like, what are the tasks that Niagara provides an API for, which we can take advantage of to really speed up and allow the technician to focus on more important things than wasting time clicking and repeating the same task over and over again. So that's where this module was born from. But this is more on the aspect of programming control sequences. So what are common complex control sequences, and how can we essentially design blocks that speed up programming, wire sheet programming, and implementing these control sequences with the idea of reducing how many blocks you need, reducing onboarding time. A common thing I heard in multiple different conferences is labor shortages and companies being understaffed. So when you're bringing on new people and you have to train them on how to program a 4-stage lead lag, it takes a lot more time to get to that point versus just turning on a fan based on a set point. So how do we speed up the amount of time or reduce the amount of time that it takes to train new people? And then the other benefit with complex sequences, typically you would have a lot of blocks, and that makes maintaining the logic a nightmare. But if we're able to look at how can we essentially abstract certain parts of complex sequences and introduce blocks that perform that functionality, then that would reduce your wire sheet code to be a lot more readable and a lot more maintainable for the future. So we have a bunch of blocks in this module, but I wanted to highlight our lead lag block, demand counter, some of our select blocks, alarms, and the weather block. So I will switch to Workbench now. So this is what our palette looks like. You would install it on your Workbench as well as whichever target controller this would be going like programming. We do provide a guide help. So in the guide help, we have a list of all the modules that exist. You can search for certain keywords, like if I want what alarms I have, and I'm going back to my lead lag. So again, every block has a help document associated with it, a wire sheet example, and for every slot, an explanation of what the slot does. Okay. So in this example here, I have a, this is the lead lag block over here. And this block allows practically an unlimited amount of stages. It's very straightforward, just to demonstrate how you would create the stages. So when you drag and drop it, it comes with 2 stages, 1 and 2. And by stages, I mean the amount of equipment that you intend to control with this block. So then I can go to my actions, create stages, and let's say I have, I don't know, 6 stage boiler. So that's it. That's all we have to do. We don't need to introduce a lot of different blocks. Like this by itself will stage the 6 boilers on and off, and based on the feedback that we receive from the boilers and how many stages we want on at a time, the block will intelligently react to what's happening on the outside. And the goal of the block, what it's trying to do is maintain a certain amount of equipment on based on what you're requesting. So if I want 3 pumps to be on, the module will stage the equipment such that, or send out commands such that at the end, we have 3 pumps on. And then if one of the pumps, for example, fails, we send a command and we don't receive a status back, then we go to the next pump. This block also lets you control the order of the equipment, the priorities. So if you notice here, I have stage 1, so equipment pump 1 is actually priority 3, pump 2 is priority 1. So when I request one pump to be on, then pump 2 will come on first because pump 2 is priority 1. And then if I request 2 pumps on, which is in this case, in this example that I'm showing, I'm requesting 2 pumps to be on, then the block will turn on the pump 2 and then pump 3 because pump 3 is priority 2. And it encodes the commands into a binary number, and then we have another block which converts the binary bits into that converts the binary number into the corresponding bits, and then we send our commands. So as I said, I wanted 2 pumps to come on, then pump 2 is true, and pump 3 is true. Now, for demonstration purposes, I just have the commands linked back to the statuses. But now let's say that pump 2 fails. We lose the status of pump 2. So I'm going to override this as off. So now what's going to happen is the block is going to react and see that we want 2 pumps to be on. I only have 1 pump on, which would have been pump 3 at that time. So then it's going to go up the priority list and see that, okay, well, the next priority after pump 3 is pump 1. So then it will turn on pump 1. And that's why we have it here. Now, if for whatever reason pump 2 ends up coming back on, then the block again will react and see that, okay, now we have too many pumps on. Well, we have to start staging down, and it'll turn off pump 1, which had the lowest priority. Now, all of this can be controlled. The staging delays can be controlled through the properties, as well as the priority list. So the priority list is just a string. You just put the order that you want things in. So right now I want 3, 1, 2. I could do 1, 2, 3, 3, 2, 1, etc. And finally, we can also control if we want to put certain equipment into into service, for example, and have it disabled and easily controlled through the graphics. Then we also support a stage exclude, so you can exclude certain stages, and then the block will intelligently react to that and while maintaining its sequence. So just quickly, I will also go over our demand counter block. So the demand counter has 2 primary uses. One is for calculating how many stages should come on. So whereas in the previous example, I just had a static number going into my lead lag. But here, let's say we have a PID loop, and if a pump modulation is higher than 95%, then we want to ask for 1 more pump because the load on a single pump is too high. So here I'm simulating a percentage. If I say that this is at 96%, then right now I'm requesting only 1 pump to be on. But now that we're higher, after 10 seconds, we will go to 2 pumps. And this block here, again, everything, it counts up and down, and how much it counts by and how long it waits before it goes up and down is completely configurable. So this can be used for staging the number of equipment. Another common use we've seen is by controlling the offset from a certain set point. So here I'm just showing a very basic example where my AHU supply air temperature is reset based on the outdoor air temperature. But we also want to add an offset to that where based on the number of cooling requests that are coming. So if we have a lot of VAVs that are starved for cooling, then we want to start adding an offset to our calculated supplier temperature set point. And then again, this demand counter block can be used for that. So in this example here, I want to decrease my supplier temperature set point by 0.5 degrees. I put it as 5 seconds so it can quickly change, but you can put it as 5 minutes. So if you want to start decreasing your set point every 5 minutes, that can easily be done. And we have a lot of other blocks, as you can see, but we're short for time. We do provide an examples folder, and that's where I got most of my examples. So if you want to see how certain sequences are implemented, that can easily be done. Rotation sequences. These are the demand counter and the lead lag is probably our most complex inside here. But I also wanted to highlight some of our other more utility blocks. So these select blocks, you can select change an output based on the status of a point. So if a point is coming as fault or as disabled, then you can choose to have a different value being passed through. We have time offset. So if you want to add a time offset blocks for that. Edge detect blocks, so sending a trigger based on a rising edge or a falling edge. Hysteresis floating output, and a couple of other blocks here. So you could do a station restart or a platform restart. You can simulate a status. A lot of times when we're programming sequences, we want to see how our logic is going to react to certain status. So we have this block here which simulates a status. And finally, our weather block, where this connects to the Open Weather API. So you just drop your API key. And for simplicity's sake, we just pre-built the slots here. But yeah, you just drop the API key, and then it populates the most common information that people would need. Okay. Yeah, so the Nimbus function blocks is an RT profile, meaning that it has to be installed on the target controller. We are targeting 4.10 and above. And then in terms of licensing, it's per controller. Licensing is the current model that we have. And yeah, we are in the market with Niagara. We love Niagara, and we want to expand what tools and like how we can help out. So as Pavlo mentioned earlier, the marketplace is to bring developers and integrators together, and we have integrators and developers at our company, and we see a lot of places that can hopefully improve the industry. But if you have any ideas or suggestions, please reach out to us, and we'd love to get in touch. Thank you.
Thank you, Omar. It was a very interesting presentation indeed, and I think it sparked some of the questions already in the Q&A chat. So thank you very much for your presentation. And for the audience, here you can see the QR code to Nimbus functional blocks. You can scan it if you want to get right directly into the marketplace page with the application, or you can go to the niagaramarketplace.com, use the search function, and find the application this way. All right, so I'm gonna give a few more seconds if you want to scan the QR code. All right, so now it's a Q&A. Now it's a Q&A time. So let's see, we have a few questions in the Q&A chat. I'll read through the questions, and then Omar or Chuck, you will answer. Depends on whose question related to. So the question says, how do you provide for equipment rotation with your lead lag? It was very fresh question, so I guess it's for Omar.
Yeah, so the equipment rotation. So the block itself has a rotate action. you could just trigger the action and then it just shifts the equipment down by one. That's one way to do it. The other way is we have a slot called stage priority, which depending on how many stages you set up your block with, let's say in my example it was 3 stages, then I provide a string comma separated um, for each stage which priority it should have from 1 to 3. So I can do like 3, 2, 1, 2, 1, 3, and what you can do is you can have an enum block with these pre-built, and then if someone wants to manually change them through the graphics, they could do that.
All right, thank you. And there is another question for function block. It says, is the function block sold per host ID or a one-time fee and can be applied to many sites?
Yeah, so our current model, as I mentioned, it's per host ID, and then yeah, so it would have to be purchased per controller, per host ID.
All right, thank you. Are there any other questions from the audience? All right, I think we can move on. And if you come up with a question, you can always reach out to either Chuck or Omar or ourselves, and we will make sure that your question is answered. All right, so what's next? All right, where can I find more Tridium talks? So we have a lot of Tridium talks. We have Marketplace Content Spotlight, we have new products, we have all the multitude of different topics we are covering with the Tridium talk. So you can go on the tridium.com and you can find on the top right side the Tridium talks, and there will be all the Tridium talks. I think they're all hosted on YouTube, and you can see them either from our side or from the YouTube directly. And we strongly encourage you to do because there is a lot of interesting information on the Tridium Talks. And of course, don't forget to sign up for the uh, all the next one's Tridium Talks. We are doing the Marketplace Content Spotlight once a quarter, at least for now. We see how it goes. Maybe we'll change the cadence, but for now it's just once quarterly. And we do have a Marketplace newsletter. If you haven't seen it, look into your mailbox. And if you haven't received it, please make sure that you go on the Tridium.com website and sign up to receive Tridium communications. And on this note, I want to thank you for participation and joining our Marketplace Content Spotlight. I want to thank Chuck and Omar for great presentations, and we look forward to see you on the next one. Have a great rest of the day. Goodbye.